group element and third year group element. So last class I started first year group element, I completed, I guess. Even second year group element also I started. Is it correct or not? Till where I completed second year group element? Can you tell me, anyone, please? Till where I completed second year group elements? Please, you need to answer. Second year group elements. Second year group elements. I hope I started. So in that second year group element, beryllium, magnesium, calcium, strontium, barium, radium. There are this type of elements are there, I told you. After that, radium is radioactive element. Its half-life is 1600 years. Correct? Is it correct or not? After that, what is the minerals of magnesium, minerals of calcium, and what is the electronic configuration of beryllium, magnesium, calcium, strontium, barium? All the points I completed, I guess. Yes or no? Please let me know. Did I complete it or not? Hello?
You did, sir.
Yeah. Next, after that, general properties I completed, I guess. General properties means first one, atomic radii. Atomic radii. Ionization potential I completed. Third one, hydration enthalpy I completed. Hydration enthalpy. Can you tell me, anyone, what is the order of hydration enthalpy in second A group? Please revise once fast. Please revise fast. Hydration enthalpy order of second A group element. What is the hydration enthalpy order of second A group element? Please, can you answer? Hello?
So which chapter you're doing?
What, ma'am?
Which chapter you're doing, sir?
I'm not able to hear your voice. Tell me.
Now you can hear, sir.
Yeah, yes, ma'am.
Which chapter you're doing, sir?
Second A group element, S block elements.
Okay, sir. So day
That
before
is
yesterday, that one,
day before yesterday,
that you took class, no? So that time which chapter?
hydrogen and its compounds.
Okay, sir.
Second A group element, what are the elements are there? Beryllium, magnesium, calcium, barium, radium. Radium, what is the half-life? 1600 years. Is it correct? What is the occurrence also I completed? General electronic configuration. Electronic configuration of beryllium. Can you tell me, please? Beryllium atomic number 4, 1s2, 2s2. So this is called helium 2s2. Magnesium atomic number is 12. So 1s2, 2s2, 2p6, 3s2. And neon 3s2. Correct. Magnesium atomic number. Calcium electronic configuration 20. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So till instead of here you can write argon. Argon 4s2 is the electronic configuration of calcium. And strontium 38, directly I am going to writing krypton 5s2. And radium and barium. Barium is 50s, 56 is xenon. Its radium is 8, radon 7s. Is it clear? This is the electronic configuration of any group element. Any doubts is there in the secondary
No,
group
sir.
element? Next one.
Sir, 1 minute, sir.
Yes, yes. You can complete fast.
Okay. Sir.
Next. General property. The general property. Atomic radii. You know very well atomic radius from left to right decreases, from top to bottom increases. In period atomic radii, what will happen? It decreases. In group atomic radii increases. Atomic radii increases. Yes. Then compare with first year group element and second year group element. Alkali metals and alkaline earth metals. Alkaline earth metals atomic radii. Alkali metal is higher atomic radii, larger atomic radii than compare with first year group element. Is it clear? Alkali metals are larger than alkaline earth metals due to effective nuclear charge increases. Next, after that, ionization enthalpy. This and all, I guess, yes or no? Ionization enthalpy. Ionization enthalpy, first ionization enthalpy. First ionization enthalpy. Generally, ionization enthalpy from left to right increases, top to bottom decreases. So that's why first ionization enthalpy, then compare with first year group element and second year group element. Second year group element is larger than first year group element. First ionization enthalpy. While coming second ionization enthalpy, first year group element is larger than second year group. Now, what is the ionization enthalpy? Amount of energy required to remove one or more electron from isolated gaseous atom. That is called ionization enthalpy. See, metal becomes metal plus losing of one electron. In the metal electron, that becomes metal ion. That is called first ionization. So what is second ionization enthalpy? M plus, in the M plus we are going to removing one more electron. It becomes M2 plus. This is called second ionization enthalpy. I am talking about first ionization enthalpy. First year group element less than second year group element. Second ionization enthalpy, first year group element is greater than second year group element. Generally, from left to right in period, ionization enthalpy increases. Top to bottom, ionization enthalpy decreases. Is it clear? Hello?
Yes, sir.
Note this point, please fast. Please complete fast.
Done, sir.
So 1 minute, sir. Okay, sir.
Yeah, next. Please note down hydration enthalpy. Hydration enthalpy. Generally, the hydration enthalpy of alkaline earth metal metals ions decreases with increase in ionic size. Increase in ionic size. Suppose beryllium 2 plus, magnesium 2 plus, calcium 2 plus, strontium 2 plus, and barium 2 plus. While going down the group, size increases. Is it correct or not? While going down the group, size increases. Size increases, hydration enthalpy level decreases. Hydration enthalpy decreases. So that's why what is the order? Ve2 plus is the greater hydration enthalpy than Mg2 plus, than Ca2 plus, then Sr2. Be2 plus is, hydration enthalpy of Be2 plus is 2406. 2406. And magnesium 2 plus is 1929. Calcium 2 plus is 1632. Sr2 plus 1485. Da2 plus 1276. So this is the hydration enthalpy. While coming from top to bottom, Be plus has more hydration. So that's why Be2 plus is greater than Mg2 plus, is greater than Ca2 plus, is greater than Sr2 plus, is greater than Mg plus. So alkaline metals are more extensively hydrated. Alkaline metals are more extensively hydrated than those alkali metals. So that's why MgCl2 formed in the form of, and CaCl2 is in form of MgCl.6H2 and CaCl2.6H2. It will exist in hydrated form MgCl2.6H2 and CaCl2.6H2. But NaCl and KCl, this type of hydrate will not possible. In NaCl and KCl, this type of hydrate is not possible. Since we clear this point, so it will exist in the form of hydrated molecule MgCl2.6H2O and CaCl2.6H2O. But NaCl and KCl, this type of hydrate is not possible. Please complete first. It's completed. Hello.
Done, sir.
Next, even beryllium chloride. Beryllium chloride also will exhibit in the hydrated form BeCl2.4H2. BeCl2.4H2. In hydrated form, it will exist like this. Otherwise, it will exist BeH2O taken 4 times and 2 plus. This is called berylate ion. Berylate ion. So it is acting as a Bronsted acid. Please note this point. Bronsted acid this is. Even beryllium will exist in the form of BeCl2.4H2. And magnesium chloride will form Mgl2.6H2. Calcium will form calcium chloride.6H2. So then compare with alkali metals, alkaline earth metals has more hydration enthalpy. So now please listen after this melting point of secondary group element. Generally, what is the order of melting point? Beryllium is greater than calcium, is greater than strontium, greater than barium, is greater than magnesium. So exceptional case, magnesium is the lowest melting point, beryllium is highest melting. Reason for this type of melting point because of it has different crystalline structure. Crystalline structure. Based on the crystalline structure, we can decide melting point of the particular element. So in secondary group element, beryllium has highest melting point, magnesium is least melting point. Even I can say boiling point order. In the boiling point order, beryllium, barium, then calcium. Beryllium, barium, calcium, strontium, and magnesium. Even boiling point order, barium has highest boiling point, then compare with barium, then compare with calcium, then compare with strontium, then compare with magnesium. Magnesium is least boiling point, least BP. Beryllium is more BP. Here, beryllium is more MP and magnesium is least MP. Please note this point. What is the reason for this? Means two different crystalline structure. Due to different crystalline structure. These questions they will ask definitely for competitive part. Even what about density? Density of the secondary group element generally alkaline earth metals or light metals. Density of alkaline earth metals decreases down the group. Generally beryllium to calcium density decreases. Beryllium to calcium density decreases. After calcium density little bit increases. What is the reason for that? Due to crystalline structure. That is the reason. Crystalline structure. So what is the order? Please note down density order. Calcium is less than magnesium, is less than beryllium, is less than strontium, is less than barium. This is the order of density. So which is the least density in the secondary group element? Calcium is the least density. Highest density is beryllium. So generally beryllium to calcium density decreases after calcium density little bit increases. That's the reason is the beryllium is different crystalline structure and magnesium is different crystalline structure. Calcium is different crystalline structure. No. So due to the different crystalline structure, the boiling point, melting point, density order will change. Is it clear? All are important for competitive part.
Sir, according
Yes,
to
ma'am.
micro schedule, you need to do P block elements, no, sir.
Yeah, I'll teach. Don't worry. Today, actually, these points are I think correct or not?
Yes, sir.
These points until I covered already.
Yes, sir.
Yeah, I'll do. Don't worry. I'll complete.
Okay, sir.
Can I go to a little bit fast?
Yes, sir.
Yeah. After density, please note down flame test. Flame test. Can I erase this page?
Yes, sir.
Flame test. So generally, beryllium and magnesium do not form flame test. Do not form flame test. What is the reason for magnesium, beryllium do not form flame test? Huh? What is the reason? The flame energy not sufficient. Flame energy is to cause excitation of valence electron. To cause excitation of valence electron. That is the reason beryllium and magnesium do not have flame color. But calcium have brick red color and calcium have crimson red. Barium have apple green color. Green color. So this is you need to remember this. Radium form red color. So this is the flame test. Flame test for second element. Next, color and magnetic property. Magnetic property. Color and magnetic property. Generally, alkaline metals are bivalent ions. Alkaline metals are bivalent ion. G1. Generally, alkali metals are bivalent ion M2 plus ions. M2 plus ions has no unpaired of electrons. No unpaired electrons. Hence, it is a colorless, diamagnetic nature. Please note this point. Alkaline earth metals are colorless and diamagnetic nature. Diamagnetic nature. Alkaline earth metals are good conductor of electricity and thermal conductivity. Alkaline earth metals are good conductor of electricity. Earth metals are good conductor of electricity. Yes, clear this points. Flame test, flame color you need to remember. Beryllium and magnesium do not have any flame color because of the energy not sufficient to cause excitation of valence electrons. And calcium will give brick red color, barium, strontium will give crimson red color, barium will give apple green color, and radium will give red color. What about diamagnetic? What about magnetic property and color property? Generally, alkaline earth metals are bivalent ion. There is no unpaired of electron. That's why it is a colorless, and it is diamagnetic nature. What about electrical and conductivity property? Generally, alkaline earth metals are good conductor of electricity. Good conductor of heat and electricity due to presence of two loosely bound valence electron in per atom. What is the reason for good conductor of electricity? Yes, can I erase this page?
Okay, sir.
Yeah. Electrical and thermal conductivity. Electrical and thermal conductivity. Alkaline earth metals are all good conductor good conductor, good conductor of heat and electricity. Good conductor of heat and electricity. Due to presence of two loosely bonded electrons. Loosely bonded held valence electron. Yeah. Next, electropositivity. Electropositivity and metallic character both. So electropositivity and metallic character in period. Electropositivity and metallic character decreases. In group, what will happen? Increases. In group, what will happen? Increases. So positivity down the group increases. That means beryllium, magnesium, calcium, strontium, barium, radium. Down the group, electropositive character increases. Down the group, metallic character also increases. Down the metallic character also increases. Hello?
Sir, what type of questions will come from this chapter? Will question.
What?
Sir,
What type of?
what type of questions will come from this chapter in JEE Mains?
Yeah, that's why I'm asking. In second A group element, what is the melting point order?
Oh, so
In second,
they will ask the order.
yeah, order they will ask.
So
in-
no, we don't have to calculate anything.
No.
Okay, sir.
In second A group element, what is the hydration enthalpy? Which one is more hydration enthalpy?
Okay, sir.
In second A group elements, which element do not shows flame test, flame color?
Okay.
In second A group element, which one is brick red color? Which one is crimson red color? Why? What is the reason for that?
Okay, sir.
Yeah, what will happen? Metallic character down the group, what will happen? Like that type of questions will come.
Okay.
Reducing nature. You didn't see the level 1 and level 2 questions? Alkaline earth metals are good reducing agent. Alkaline earth metals are good reducing agent. Are good reducing agent. Alkaline earth metals are good reducing agent. So it is due to, what is the reason for that? Due to down the group, this nature, what will happen? Increases. Generally, in this group, in second A group, barium has more reducing nature than strontium, than calcium, than magnesium, than beryllium. Barium is the highest reducing agent. Then compare with strontium, compare with calcium, then compare magnesium, then compare with beryllium. What is the reason for that? So E naught value, electrode potential value is very least. If it is electrode potential value is least, it is a strong reducing agent. In whole periodic table, which is strong reducing agent, lithium is strong reducing agent. So then compare with first A group element and second A group element, which is strong reducing agents. First A group elements are strong reducing agent. Yes. Is it clear?
Yes, sir.
Yeah. Next, I'm going to chemical properties of secondary group elements. Please complete fast. Chemical properties of secondary group element. Just can I erase this page?
Yes, sir.
Please note down chemical properties of secondary group element. In the chemical properties of secondary group element, first one react with air. And we told you this one also. Generally, alkali metal react with oxygen, air will rise to MO type of oxides will form. MO type of oxides means, please listen here, BeO type of oxide, MgO type of oxide, and CaO type of oxide, SRO type of oxide, and BaO type of oxide. Here, M means either we can take beryllium, calcium, strontium, and alkali type of peroxides will form. So generally, what are the peroxides will form? Strontium, barium, O2 type of peroxide. Yes. Please, you need to remember here one point. So what is the basic nature of oxide? Then basic nature of oxide. Definitely they can ask. Basic nature of oxide, down the group increases. BeO less than BaO. Basic amphoteric oxide. Please note this point. And one more point, BeO is covalent. But rest of the oxides, even so, this is insoluble in water. BeO is insoluble in water because of it is covalent. But rest of the oxides are ion. It is soluble in water. Yes. BeO and MgO is insoluble in water. Rest are soluble in water. BeO, MgO covalent character. Rest of the oxides are called ionic character. Down the group, basic nature of oxide increases. PeO is amphoteric oxide. The rest of the oxides are ionic oxides. Has any doubts is there?
Yes, sir.
Clear these points?
Yes, sir.
Complete fast. Next, can I erase this page now? I'm going to erasing this page. Next, action with halogen. Action with halogen. What type of halides will form? Alkaline earth metal. Alkaline earth metal react with halogen. X2. MX2 type of halides will form. So where M means I can say beryllium, magnesium, calcium, strontium, barium. X2 means either fluorine, chlorine, bromine, iodine we can take. So what type of halides will form? MX2 type of halides. MX2 type of halides means BeCl2 type of halide, MgCl2 type of halide, CaCl2 type of halide, or SrCl2 type of halide and BaCl2 type of halide. This type of halides can form. So generally what type of questions will come here? Please listen. BeCl2. So we can prepare BeCl2, beryllium oxide, react with carbon, react with chlorine plus carbon at 600 to 800 Kelvin will give rise to beryllium chloride plus carbon monoxide. This is the preparation of beryllium chloride. Rest of the chlorides you can prepare like this. So here, please note this point. Beryllium chloride is covalent nature. Covalent nature. Even MgCl2 covalent nature. So BeCl2 and MgCl2 both insoluble in water. Insoluble in water. Beryllium chloride and both covalent nature, insoluble in water. Rest of the chlorides are ionic nature. Rest of the chlorides are ionic nature. Yes. Any doubts? Halides can prepare Can I erase this page? Is completed or not? Hello? Can I start next? Next, please listen. So metal halides can prepare metal react with HX. Metal halides will form MX2 type of halides plus hydrogen gas will come. Metal hydroxide react with HX. Metal hydroxide react with HX will give rise to metal halide plus H2O. Next, metal carbonate react with HX. Metal halides will form. Plus carbon dioxide plus H2O will form. This is the preparation of metal halides. Except BeCl2, rest of the halides are ionic nature. So this is covalent nature. BeCl2 is covalent nature. It insoluble in water. Insoluble in water, but soluble in organic solvent like ether. BeCl2 is electron deficient molecule. Electron deficient molecule. It's called electrophile. Electron deficient Lewis acid. This is called Lewis acid. Now I'm going to write the structure of BeCl2. BeCl2 structure I will write. What is the structure of BeCl2? Yes, did you complete? Structure of BeCl2. This is most important. In vapor phase, it is a dimeric structure. Dimeric means like this: beryllium, this is the dimeric structure. In dimeric structure, beryllium undergoes sp2 hybridization. It's a planar structure, trigonal planar structure. Trigonal planar structure. In solid phase, it's a polymeric structure. Please note this point. In solid phase, it is a polymeric structure. BeCl in polymeric structure. In polymeric structure, B is sp3 hybridization. Tetrahedral structure. Hedral structure. At high temperature, beryllium chloride is linear structure. Linear structure. In dimeric vapor phase, it is a dimeric structure. In solid phase, it is a polymeric structure. In high temperature, it is a linear structure. Linear structure means beryllium undergoes sp hybridization. In linear structure, beryllium undergoes sp hybridization. Is it clear? Beryllium chloride exists in the form of vapor phase, solid phase, and high temperature. In vapor phase dimeric structure, their sp2 hybridization planar structure. In polymeric structure, it is a tetrahedral structure. It's called sp3 hybridization. At high temperature, it is a linear structure, sp hybridization. This is about beryllium chloride. After this, to react with hydrogen. Completed. Hello. Hello.
Yes, sir.
Completed those reactions.
Sir, 1 minute. Yes, sir. Done.
Yeah. Next, react with hydrogen. React with hydrogen. Except all elements except combine with hydrogen. Combine with hydrogen. Hydrogen forms hydrates. What type of hydrate will form? MH2 type of hydrate. So beryllium hydrate can prepare BeCl2 react with lithium aluminum will give rise to BeH2, beryllium hydrate plus LiCl plus AlCl. So this is the beryllium hydrate preparation. All the elements except beryllium combines with hydrogen forms MH2 type of hydrate. So beryllium hydrate you can prepare from beryllium chloride react with lithium aluminum hydrate, beryllium hydrate will form. Here B MgH2 both are covalent characters. BH2 and MgH2 both are covalent character. So BH2 and MgH2 both are polymeric structure. B this is called polymeric structure. Even MgH also polymeric structure. Both are covalent character. It is insoluble in water. Rest of the hydrates are, what are the hydrates will form? Beryllium, magnesium hydrate. These two are covalent nature insoluble in water. Rest of the hydrates, calcium hydrate, strontium hydrate, barium hydrate. These all are ionic characters. So these all are ionic character. This is called saline hydrate. What type of hydrates they are called? Saline hydrate, thermally stable. One more name is there. CH2 is called hydrolith. CH2 is called hydrolith. Please note that point. Please ask any doubts. Please, any doubts is there, you can ask.
We have
Able to hear
completed.
me or not? Yes, ma'am. Remaining tomorrow I will continue. Yes, is it fine? Tomorrow I will continue from action of hydrogen completed. Next one, react with diluted acid, water, then anomalous behavior, diagonal relationship. I'll complete tomorrow this chapter. Thank you. Thank you.
Thank you, sir.
Thank you.